Hello everyone, welcome back. And in today's video we're going to be getting a more in-depth closer look as the new system creeps closer and closer. We're going to look at a few different computer models and maybe some overlays. I don't know for sure if they'll work or not. I'll definitely try. But as we go into the weekend, as we creep closer to the weekend, I believe on the 20th, I think, if I remember correctly, there is a chance that we could see some form of weather. And it's not for certain yet. I'm not 100%. Um, I'm not 100% certain. I don't know how well it's going to hold up. Obviously, that's why we look at models to see. But if it does hold up, I don't know how much of a threat it poses to, people that I know and people up in Nebraska, but it could pose a bigger threat for people down in, like, say, Kansas if this thing stays farther south, like I'm thinking it will. But let's look at some lapse rates for Sunday. As you can see over here in New Mexico, it's about every time you get a kilometer higher up in the atmosphere, the temperature changes about 8.1 degrees Celsius. So a lapse rate is the difference in temperature the higher in the atmosphere you go. So from the ground to 1 kilometer in the air, the temperature changes by 8.1 Celsius, and then another one, and it gets colder and colder as you get higher in the atmosphere. So, uh, if we go to Cape, we have just a little bit, 1150 joules per kilogram. So, um, severe storms need about 100 Cape to form, and tornadoes can form at 500 Cape. So, just because your Cape is below 1,000 does not mean you can't get a tornado. You can get a tornado with 500 Cape. Typically, they're not strong, but weird things have happened. Um, if we go to surface-based CIN, which is the cap, meaning which does involve the measurement for Cape. It's Cape inhibition, basically meaning how stable is that environment. So like here we have negative 227 joules per kilogram, meaning the higher the negative number, the stronger that cap is, meaning the more stable that area is. So if we look for example, down here, I mean that's negative 302. That's a strong. That's very stable. If you go out here like light gray, -3, meaning a little like a normal springtime shower goes through, and then severe storm goes through. That severe storm will be able to ramp up fast if it wants to, and it could be bad. But as the scans go on, you can see that the cap does get stronger out here in western Nebraska and really strong out here in Texas, which, from what I saw, is expected. And then you can see, boom, another scan later, that cap is gone. So something happens out here that just diminishes that cap. And I mean, diminishes it to like negative 27 joules per kilogram, to basically nothing. Okay, let's go for another one, see if the cap rebuilds itself or what happens to the cap here. Yeah, as you can see, now the cap is pretty much gone here. So this whole area now is susceptible to severe strong storms. If we go to like wind shear, for example, how strong the winds are above the surface here, we'll see what the winds up aloft in the atmosphere are doing, and that'll help give you a better understanding of, you know, the tornado probability in your area. Um, right now I'm having the computer's being slow. I haven't used the computer in over 2 months, I don't think. So computer's taking his time. Um oh, and the whole page is reloaded. But okay, so here you go. Here's your wind shear. Hey, here's what your winds are doing up aloft, okay? I mean, they're whipping 70 knots, 80 knots. I mean, the winds are whipping up there. I mean, out here we got 33, so I mean, that's still fairly strong. But you do know that if you've got strong wind shear, depending on what it's like down at the surface, you could get some pretty volatile and some pretty dangerous storms with that. If we go to storm helicity, um, whoa. I mean, this is right here. Which is odd because all models show a fairly decently strength cap right here. Remember, the gap for the cap was like right here. So right here, this is interesting. They have what looks like to be some fairly decent chances of storms popping up right here. I don't know if they're moving this way or if it's gonna be in a line that extends and it moves out to the east. Um, so and yeah, so it looks like that's what they think is it's gonna form a line from about the extreme northern tip of Texas, the Panhandle, Oklahoma, and go north into Nebraska, and then track eastward into. And then this one shows that it breaking up. So maybe a cap forms out here, and it it makes it so nothing happens. But then again, it weakens. Nope, I don't want the photographs and stuff. But it weakens again, and then we have another stronger surge right here in about north central Kansas. Come early Monday morning. Whoa. I mean, eastern Nebraska on the 21st, early 21st morning, could be in for some early mornings, as it looks like we could have some pretty strong. I mean, what is that? 520 meters squared. I mean, you could be in for a rough and loud morning in eastern Nebraska. Again, don't know how well these models will hold up. It's still pretty far out in the future, a little more into the future now, and it looks like it weakens as it gets later into Monday. And I think by Monday night into Tuesday morning, it should all be relatively out of the area. Yeah, as you can see now, it's starting to weaken. And at this point, all the severity would be gone. So you just, between the midnight to, I'd say, midnight to 3:30 in the morning, don't be surprised if you get woken up by some pretty loud thunder, or if you have a NOAA all hazard radio, weather radio, don't be surprised if that goes off once or twice for your area. Um, in terms of like a tornado threat, I don't think there is one. Obviously, like I said, there is a lot of spin in the atmosphere, as you see by the photograph. Possible hazard type is 0. Like there isn't any. I just think there'll be strong, like heavy rain. Um, but then again, I am by no means a meteorologist. Okay, I want to be one. I am not one, so I don't know how well these models are going to show up, like how well they're going to hold up. Let's go to the supercell composite and let's see if that lines up. So it does not. So These two models are contradicting each other and they are not agreeing with what each other shows, which isn't all too rare. I mean, it happens more than you think, where you look at one model and one model doesn't agree, but the other one does. Um, so supercell composite meaning within a given area. I don't know how big the area is, but they're within a given area. They're saying there's going to be 3 supercells within this area. Okay, and this area does hold a potential marginal tornado risk. I mean, as you can see down here, EF0, EF1. Like I said, look at the cape. Surface level cape, 713 joules per kilogram. Tornadoes only need 500 to form. Okay, the spin in the atmosphere, all the ingredients, wind shear, cape, daytime heating, it's all there for tornadoes to form. They won't be strong. I do not believe that they will be strong tornadoes. But crazier things have happened. I mean, if I'm sure a lot of you guys heard about Milton. I mean, like 26 confirmed tornadoes as of now. I mean, so crazier things have happened. Let's see how big of an area we're looking at. Okay, so here looks like they do have a tornado risk. It's not as high, but they do have one. They have more cape, but they don't have their photograph isn't as good looking, I guess, in terms of it goes spike up and then it's kind of level and then it dips down and then it shoots up kind of weirdly. So that don't look too concerning. But yeah, I think that'll be it for today's video, guys. If you enjoyed, make sure to hit that like button. Let me know down in the comments what you thought. If you're new around here, make sure you subscribe so you never miss a video. And you know what, I am going to see you in the next one. Peace.